I might have done something bad. This is definitely not recommended. If you like your meter, we're probably being alive. Carefully set this down. Yes, it gets hot. Fantastic. 0.03 volts. I don't think that's accurate. Alright, so I got this hot plate from Goodwill. I was going to use it to heat up my etching solution for the titanium keys that I make, but the thermostat on the front is not nearly precise enough to keep that etching solution at just below a simmer, I guess. If it boils over or gets too cold, it's not gonna be good times. So I thought I would scavenge this old pile of parts from the 3D printer head. I won't be using the 3D printer anymore. I use the machine for work too much, and I would like to build a 3D printer at some point, but I will do that later, and I don't need the parts right now. So let's take this thing apart and see if we can apply a PID controller to it. I opened this thing already just to see how the thermostat works, and I'm not really sure. It's got this control here, and as you adjust the thermostat, it pops that little relay looking contact in and out. I don't know if you can see that, but I'm not sure where it's getting the temperature from, because is it just taking this moves like it might adjust with the temperature, but is it just taking the temperature of inside the enclosure here? I'm not really sure, but it's nice and simple. So the first thing we're going to do is remove one of these leads. I guess technically it doesn't matter which one. Red is maybe live, so we'll switch that. Do I want to still use this switch? I don't think so. I don't see any reason to do that. So we can probably just disconnect this guy and send that across the relay. So let me can get these things off. And actually, let me see if I have some of the little spade terminals for these. You know what, even better, these little Wago terminal blocks. Big Clive recommended them, and so I got myself some, and they are super handy. Strip this guy back. And in. Strip this guy back. Done. And actually, before I get any farther on this, I do need to waterproof this. I guess that would be a thermistor? No. Yeah, thermistor. Not thermocouple. Doesn't matter. But I'm not really sure if this exposed metal point can be submerged in water or not. So, just get this off here. I have a neat plan for this, which will move over here. Don't mind the mess. Where'd it go? UV curing epoxy, or UV curing resin. I guess it's not really an epoxy. Dip this guy in here. Let that drip off for a minute. If it wasn't so cold out here, this would be a lot more runny. It's probably good. Plug in our light. This stuff will just cure in regular light or in sunlight, but UV goes quite a bit faster since it's UV curing resin. There. Maybe it'll be fine. Alright, back to work. Alright, so we've got, this will presumably be live. It doesn't really matter, but I believe it's standard practice to switch the live. I'm not really sure. It's AC, so I don't care. That will go to the relay here, which this is a 10 amp 250 volt relay. I don't know if this draws more than 10 amps. I guess we'll find out. You know, now that I've got these on, we should probably find that out first. One moment. Oh no, I blew my fuses. I forgot about that. I was checking something in the homemade CNC machine, and I accidentally shorted between two live and neutral pin. Actually, I think it was 12 volts in common, but it doesn't matter. But blew the fuse. Which I didn't think about at the time, so I just switched it to the next higher up current rating and did the same thing and blew that fuse. Where the hell are the fuses? I don't have any mini. Well, I don't need the mini fuse because we're dealing with big boy amps. Fuse 2. 20 amps. It's not often that I have the right stuff. And this isn't really the right fuse, but it'll be fine. 2 amps, 250 volt, 6 amp, 4, 6, 1, 2, 3, and 5. That's not a low amp assortment. Alright, well, we are going to have to just improvise. By the way, I've started up the Patreon thing again. I've changed it to a per video basis. I don't know how many of these I'll actually be able to make, but if you're interested in helping support the videos and giving me an incentive to be out here doing this instead of working, I'll put a link to the Patreon page in the description down below. You already see what I did with that old fuse. Well, I guess it doesn't matter. I can just blow this one. We shall just blow whatever fuse is in here. This is definitely not recommended. If you like your meter, we're probably being alive. But I got work to do. And I will fix it later. Actually, I'm not even going to put this back together. 20 amps. Well, it won't be more than 20 amps. Amps AC. Another handy bit with these Wago blocks. You can stick your probe tip in and just lock it in. So handy. WAGO 221 if you'd like to get some. They're actually pretty cheap. I don't even know if they're $1 a piece. And as you can see, they're plenty reusable. So let's not burn the bench. Set this all here. Oh, for fuck's sake. I'm trying to see. Here we go. So those are in. I don't think anything's gonna short. This guy in. 8 amps. Nice. Alright. 8 amps is not much at all. So we can use that relay. Oh. Deal with that later. Alright. So this relay is good for 10 amps. Yes, 10 amps. If it was 20, I wouldn't have checked. So, output of this goes to these. I'm just going to steal these 2 wires here. Perfectly good wires. White can be, I think it doesn't matter. Here we go. Normally closed, normally open is what we want to use. Could go get some ferrules and be fancy about it. But I just need this running for now. Actually, if this works, which I presume it will, I will pretty all this up and make it quite a bit nicer later on. But I have work to do now. Shorten this guy up. There are few things in life worse than cheap terminal blocks. Alright, so this should be fine. Let's see. Input, it doesn't say, but if I had to guess, and I do because I already took this thing all apart, I'm pretty sure this was driving the, or was it driving the other relay? I think it was driving the other, well, there's only one way to find out. Actually, I guess there's multiple ways to find out. But let's just see what happens. J1 output, thermocouple solid state relay. Would actually be these two wires here. I guess we'll just see if this powers this relay or not. If I don't have it hooked up to the probe, I think it will automatically be on. But I could be wrong. I frequently am. The nice thing is this controller, which I got off Amazon or eBay, something like that. There's the focus. That's the model number, if you want to get one. They are AC. Is that why I was using 85 volts? Well, either way, they're AC or DC, which is nice. How was I powering that before? I guess it was just 110 again, just like I'll be doing here. I don't know. Took the thing apart already. And I need one more set of Wago blocks. One moment. The other nice part about Wago blocks is there's no heat shrink to deal with. So I need the other half. Let's see, so the input coming in will be through this, through here to this one. Black's supposed to be live, right? So this is always powered. This is before the switch. Alright, so this needs to go to negative, not negative, the other side of AC. Red, white, which is coming over here, so I'll leave that on since it's already got the terminal. And I will just steal power out of here. Now's probably a good time to mention don't try this at home. Although do try the Wago blocks, they are awesome. They're all common together. It's one bus in there, so anything you plug into any one of these is it's like a wire nut, but obviously a lot cooler. And easy enough to just remove one wire if you need to later. Replace it. Okay, so if I plug this in, actually this should maybe actually start working. It doesn't have the thermocouple. Let's plug that in. I wonder if it's dry yet. It's pretty well. I mean, it's not. Ugh. All right. Well, half of it's cured. Oh, whatever. Just get this thing out of the way. Would you cooperate and make a knot? Yep. All right. Let's get this guy in. Hook these guys back up. I labeled this before I took it apart. All right. So with any luck, when I plug this in, nothing should go bang. This should turn on, and it'll probably try to turn this on. Let's find out. That's on. AL, I wonder if that means alarm. This has power. It's not getting hot. This, of course, shouldn't do anything. If that's not getting hot, it probably has something to do with, well, where's the meter? Very, very quiet. I need to get a new meter. But there is continuity there. So, what? That should be getting hot, but it's not. So what have I not connected? Oh, there's our little neon light. That's not on. I might have, let's see. Live comes in here. Oh my, that's not right. That's not right at all. Oh, there's a problem. I'm just shorting that relay. No, I'm not. Alright, no, that was fine. It looked like I was. They're both black. Alright, so let's see. Power comes into one side of the relay. Oh, that is a terrible noise. Comes out the other side. It's normally, oh, Ben? What is going on? This should have continuity right now. Or shouldn't. And it doesn't. So that's right. So current flows through here, through here, through here, into here, through the coil, back out through here, and yeah, that should be fine. Oh, probably should put this back. Our live, neutral. So we're definitely getting power to don't mind me. Why do you know turn on now? Live. Oh. What have I... No. Live. Yes, what have I done here? Neutral, live. This should be here. All right. Okay, I don't know the AL. Well, the output's still. The output is on, right? Should be. Well, I mean, that won't be. Should have across these. No current. Alright, what have I messed up here? Well, I suppose the easy way to figure it out if I bridge these together, this heating element should get hot. Which it is. Alright, so that's... So it works, but it doesn't want to work through this relay. But on this relay does work. This relay does not work. I might have done something bad to this relay. Or, alternatively, I don't know. So we need a different relay, one that will respond to how many volts are you? .03 volts. I don't think that's accurate. Unless it's broken. But it was enough to light the LED on that relay board, so it's not... Oh, I'm in volts AC, for fuck's sake. Don't they make a meter that will automatically figure that out for you? 0 volts. That's because I'm on the wrong pins. Too many volts. 9 volts. Ah, Jesus, that was a hassle. Alright, 9 volt relay. 120 put. I don't know why that one wasn't working. Let me go see what I can find. Alright. Alright, I have to steal this guy off of the furnace. Not the home furnace. The crucible melting furnace thing I built. I will have to get a proper not relay like this off Amazon, but for the purposes of getting this working now, we can use this. This will take 4 to 32 volts as an input and output all the amps up to 660 volts. So we're good there. So output of this guy needs to go to the input of this. These guys. Or they're these guys now. What the hell happened to that little board? Not important. Like I said, this is purely just to get this thing running for now. And if it all works, this is our negative. If it all works, I will get it cleaned up, and probably before I put this video out. But maybe not. Positive. Don't recall where I got this relay. I think it was in an electrical enclosure I bought or salvaged. It's a hell of a relay. 45 amps. Explains the huge heat sink on it. We have 8 amps, so it should be fine. Alright, so when I plug this guy in, this light should light. Not sure if you can see that. Not even sure if this is in focus. Output. Yay, output. Okay, so now we can hook these guys one side. The other side. All right. So this should go from the wall through here, through here, through here, around the coil, back out to the wall. So this should work fine. I don't really know what was wrong with that other relay. I think I might have given it too many volts. I don't know. I think it was, yeah, because I looked on the top, it was a 5 volt. It's a 5 volt relay, but 9 volts shouldn't. I mean, it's a lot, but it's not that much. It should be not fried, but it appears to be. Okay. So now if I plug this guy in, this thing should get hot. Yes, it gets hot. Fantastic. So, for the very short term, I will... Yikes, what the hell will I do? Oh, I will clean this up and I'll be right back. Alright, we're all wired up. I'm going to actually silicone this on. Flexible adhesive, the amazing goop, pipe thread sealant, silicone. This this part of the knob here ended up being a little bit of a cable gland. Just silicone this all up. Why not? Oh, what is this? It's not mixed well. Oh, the silicone. Alright. Get on there. Need to get a something to prop that up a little bit while it dries. Nope, that's too much. I will just tape it. Will not be dumb and tape it. Using the tape roll to hold the thing on. And it's a roll of stuff made to hold things on. Sheet metal is a little thin and sharp, so I thought it would be a good idea to reuse this as a little bit of a anti-chafing measure. Get that in the middle there. Alright, let that cure. I'll take the tape off later. So, It's all been rewired. The reds, one goes to the, I still don't know which side is, well, let's see. Get the meter, which, as promised, I will take the fuse back out. Let's see. So the big side is your neutral. So red is not neutral. Okay, so red is live. Or hot, as they say. Now that I'm done with this, we'll remove this. There. See, I'm being safe. That wasn't safe. Alright, so red is hot, one of which goes to, or live, one of which goes to this. The red is always live whenever it's plugged in. So one goes to this, and one goes to one side of the relay side of the relay. The white is always neutral, so that only goes to this. So you've got a live and a neutral that power this all the time, and a live that goes here. And then when this closes the relay, live goes through black to the one side of the coil, around, and then that goes to the neutral that's in one of the Wago blocks in here. So it's really simple. We'll see how it works. I don't know if this temperature controller is the kind that will auto sense and make a control curve depending on the actual use that it's being used for. The one on the furnace will do that, but this one is like 8 times cheaper than that one. It probably doesn't, but you'll see. So when we turn this guy on, and I believe we're set to Celsius, or something's horribly wrong. It's set at 22. This guy, oh, can you see that light? Probably can't. Well, this light lights whenever this light lights. So since it is above 24 right now, I have it set to 21, I guess. So let's set it to 35 degrees, 33 degrees. And right now, this will go into the liquid, not the acid itself, but the water bath that the acid goes into. But right now, we'll just put it above the coil. So this should, you see it starts blipping the output. And I'm not sure, like I said, if this is the type that will see, hey, nothing's really happening, so let's keep the output on for longer until something happens. It might need to be run through the setup, but I'm not going to do that right now. Yeah, it's getting warm. It's not on very long at the moment. Because with the other one, it would say, hey, nothing's really changing. Let's have the output be on a little bit longer, and it would kind of automatically map how the temperature moves. This one I don't think is that smart. I'm not sure that you may just manually set it. I'm pretty sure there's facility in there to do something like that. I don't think you're just stuck with little blips. Well, we saw before when it was way off, when it thought it was set to like 17 or something, the output stayed on continuously until it started climbing. So it must do some sort of thinking. Anyway, now that it reaches 31, 32, it should stop doing its output thing here pretty shortly. or at least slow down the pulses. Yeah, see, now they're barely there, and now they're off because it's overshot now. It doesn't need, what I'm doing doesn't need to be, you know, precise down to even 10 degrees. It just has to be way better than what this thing could do. And I'll mess around with the settings. I'll look it up and see if there's a way to change that. And it should also change a lot less drastically when it's in the water. The water will soak up quite a bit of heat and distribute it a little bit better than just sitting above the coil. Alright, so let's give this thing a test. While I was waiting for these files to transfer off the SD card, I looked it up, and this does have auto tuning. That is what that little AT means. So I'll put this guy in the water here. Although this might take a while. Not sure if we'll do this whole thing or not, but let's find out. So let's see, we plug it in. This turns on. I want to set, I also looked up, I want about 65 degrees Celsius for the etching stuff. So you press and hold this button, and it says the AT light will start flashing, and now it's doing the auto tuning thing. So it's got, will you be able to see this? Let's carefully set this down. Oh. Alright, so you see the green light is on whenever, the green light's on whenever the output is on. This one's just flashing constantly because it's in auto tuning mode. And you can see the temperature is starting to rise. The probe is sitting down on the very bottom of the pan, which is probably good for this demo, but I'll redo this later with the actual setup. It says it's going to overshoot and drop back down, I think 3 times. Oh, the dropping back down is going to take forever. Yeah, I probably won't video that. It's going to have to let the water cool down. So this might take a couple hours to auto tune this. So it's actually doing a pretty good job controlling the temperature. Even though it's not up to its max yet, it's noticed it's climbing pretty quick, so it's turned off the output. Yeah, this could take quite a while. We won't stick around for all this, but yeah, you get the idea. Even this little cheap guy, Auber. It's an Auber SYL1512A. It does have auto tuning. It's got provisions for a bunch of different types of thermocouples, and I might have seen thermistors and thermocouples. Yeah, it's a great little unit. I think it was only, God, it's got to be about 20 bucks on Amazon, something like that. But you can control just about anything you want. They will do heating as well as cooling. If you want to go the other way. But yeah, I'm going to let this sit here and auto-tune for a while, and we'll see you next time.